It certainly is very complex, the whole business of innovation, because of course, there are so many different things that we'd all like to achieve. We talk about being economically savvy, and we want to be able to achieve great environmental objectives. We want to create jobs, and we want to do the right thing for society, and all of the above if possible. What I'd like to do is now bring into front focus the whole debate around green materials, because if we start to understand how, in fact, different types of industries, whether you're manufacturing industry or whether you happen to be a resource sector or what have you, the importance of understanding how to achieve those green outcomes from the context of materials can become quite complicated, because not only do you have to worry about energy resources, but you also have to worry about input raw materials. Because if you're going to make any product, whether it happens to be steel, aluminium, metal, polymer, ceramic, everything, the built environment, materials that go into manufacturing this building, for instance, you need input of materials. So that's the reason why I thought, let's bring the focus back to materials, because when you start to do that, you automatically have to think about, well, how am I actually going to deliver that product, whether it happens to be green steel, which is part of the focus of what I'm going to talk about today, or whether it happens to be a whole range of different products. And to stop and really ask, what does it all really mean? How do we actually define, in this instance, a product that happens to be green? And there's a lot of talk around, well, it's got to be recyclable, it's got to be renewable and biodegradable and all of that. And I'd like to sort of put a simple proposition to you that when you talk about a material in the context of it being green, it could span a full spectrum of opportunities. And this is exactly where the opportunities should be tapped into. Is it about reducing how much energy you need to make a product? Or is it about the input raw materials? Can you make something out of recycled waste materials? Is it about finding ways in which end-of-life products can then move on and become raw materials for some other sector? As long as you can look at a whole range of possibilities and satisfy one of those criteria, in my eyes, what you've really effectively done is done a job that's better than current practices. So the context of steelmaking was really about, as we all know, it is, again, a resource-intensive industry. It relies upon carbon materials like coal. So from our point of view, it was really saying, okay, well, if we were to look at alternative materials, and instead of using 100% coal input into these types of technologies, in addition, of course, to the metallic input that you need to produce steel, what if you could actually replace part of that coal input with other alternative materials that, in fact, do have the kinds of properties that you need? So in this instance, what we needed was the carbon input. Carbon traditionally comes from coal. From our point of view, it was about saying, well, what else is out there in terms of alternative resources? But then you could generically ask that question about manufacturing any product. So it's that sort of questioning that says you don't have to always rely upon conventional raw materials, and you can look at alternative resources, because certainly it achieves two purposes. One is the obvious one, which is, it helps you recycle end-of-life products, which of course, is an important goal in its own right. But it also helps you develop new innovative ideas that might actually result in new economies. The term branded around with green economy, well, what does it actually mean? It actually means that it gives you the opportunity to tap into a whole new resource sector. So whether that resource sector happens to be, waste materials, or it happens to be looking at end-of-life products. So all of these types of materials are effectively the focus of what we are studying at UNSW in partnership with a range of different industries. So whether they happen to be, an example of something we're looking at now is agricultural waste. And you might say, well, what does that mean? So if you think about the fact that when you're actually processing food and you're using up the edible parts of the food, there's a lot of inedible bits that are left behind. So any food manufacturing company might say, well, okay, how can I actually extract value out of this waste? So the conversation really has to be around the value that you can extract from waste, whether it happens to give you energy, as you're all familiar with, waste to energy concepts are not new, but whether it happens to then overall give you value in a broader sense by it becoming a raw material input, as it has in this particular instance, where it's become a raw material for making steel. It basically drives the whole concept of green materials, because it's not only allowing us to look at alternative resources, but as you'll see from this talk, is it's actually helped us optimize the energy requirements of the process. So in a nutshell, what we've been able to achieve here is that we've been able to reduce conventional raw materials like use of coal-based resources. Not only have we done that successfully, but we've actually shown that the process of making steel becomes more efficient. So when people start to think about green technologies and green solutions and innovations, the first thing that comes to mind is, well, gee, this must be more expensive than conventional processes, right? I mean, that's the first thing you think about. You think, is it going to cost me more? The realities are, if you start to look at it holistically, that is, am I going to save on energy? Am I going to save on raw material cost? Am I going to improve productivity? If you start to look at it holistically, what you will find is some avenues and some pathways to actually save potentially on cost as well. So it sort of gives you an economic incentive in there. Again, I'm not saying that this happens on day one, but this is where R&D comes in, where the combination of research, I think Andrew summed it up really nicely, that it is a combination of understanding what's new, what are the possibilities, and of course, trying to achieve practical outcomes from that. And that's really where this research was driven from. That we didn't want to just say, right, we're going to achieve this practical outcome on day one, but the focus was really around saying, what's innovative, what's new about these types of solutions, what kind of research do we need to have? I mean, the first simple thing is, if we are going to recycle waste materials in a steelmaking furnace, a steelmaker has the right to ask, is this going to contaminate my steel? You know, am I going to ruin the quality of steel that I'm making? It's an obvious question to ask, right? So those are the kinds of R&D challenges that we had to start to understand as part of this technology. But also more broadly, any of the other technologies that we're looking at as part of this overall picture on sustainability of materials, what we're trying to understand is that what are the benefits we can achieve? Can we reduce the cost associated with the process, with the energy input, with materials? And so that gives us the opportunity to innovate in a whole range of different areas. We've all been doing the right thing as society. We've been doing the reduce, reuse, recycle, but clearly there is still plenty of waste that ends up in landfill, right? I mean, that's the reality of it. In Australia, we end up recycling roughly about 20% of our plastics, for instance. So it's not as if we're not doing it because we don't want to. Of course we want it. I mean, as a society, we're aware of what waste issues can be. But it was really about saying, well, if we can't recycle these types of waste materials in a conventional sense, well, what else can we do? We need to obviously be quite innovative in the way we manage our waste. And the best part of it is if we can actually convert waste into value. So from our perspective, the goal of waste to value is a very simple objective. How do we then go from all of this to achieving value? And as I said, you can define value through a whole range of different indicators, whether they happen to be energy or materials. But remember, in all of this, if you can achieve savings in terms of your resources, the obvious outcome is going to be you're going to achieve cost savings, right? If you're going to use less power, you're going to pay less for energy costs. So there are all of these obvious benefits that you eventually get to if you can solve the first basic issue around resource consumption in different industries. So what it actually means from our context is that when we talk about sustainability, it truly requires that absolute innovative thinking in terms of, well, where is that going to come from? Well, obviously it's going to come from R&D. But it's so important because it just means that the whole industrial base, how we produce goods, whether it's the manufacturing industry or a whole range of different industries, how do we actually get to that point where we're going to arrive at solutions that are going to give us both environmental as well as economic outcomes. So from our point of view, just to basically finish off and conclude, what we've basically shown is that with green materials, with this approach, we can actually not only start to look at how innovative thinking can in fact enhance sustainability, but could we then start to propose this new way of thinking where we might say not only do we need to do the 3 R's, but to some extent we almost need to think about a 4th R in the process that actually says that if we go down this pathway and we still are left with waste resources, what the whole concept of reform does is says to take waste materials and to transform them into completely different raw materials and resources for different applications. So what we are doing is breaking it down, using those elements that are available to us and reforming them in a way that it becomes valuable raw materials for the next manufacturing process into which we want to put into it. So yes, of course we have to do the obvious. We've got to do the reduce, reuse and recycle. But if after that we still cannot recycle a lot of these complex materials, then what we've got to do is go down the path of completely reforming these types of waste materials, so they actually become valuable resources for our industry. And that's where I think it's going to help us promote the concept of green materials, pushing forward the whole sort of idea around green economy. So thank you very much for your attention.